Finishing up our last application problem. We ran out of time in the previous video, but we're very close. We wanted to find the area of triangle 2, knowing that when we add triangles 1, 2, and 3 together, we'll have a pretty good approximate area for the lake. But the problem is in area 2, in this triangle 2 I should say, we only had one side. But if we look back to triangle 1, it shares a side with triangle 2. I've labeled that X. So going back to the first triangle, using the law of cosines, we're going to be able to find that missing side that is shared between the two triangles. And we pretty much let the calculator do the work for us. We can take a square root on both sides here. And we'll get that calculator out and pretty much just type in the square root of 35 squared plus 80 squared minus 2 times 35 times 80 times the cosine of 15 degrees. And the wonderful thing is, right now we've taken the square root. We have that side X is about 47.1, and we can even store that in for X to use later. So that's good. At least we have another side in both triangle 1 and triangle 2. You can see I've highlighted in triangle 3 that we have side Y, and that's a shared side with triangle 2 also. So we can do the law of cosines in that third triangle. Y squared would equal 45 squared plus 20 squared minus 2 times 45 times 20. Multiply that to the cosine of 80 degrees. We noted that that was an 80-degree angle on the interior. And we're going to take the square root of that expression. And when we do, we'll get 45 squared plus 20 squared. And we'll just continue to type this out. The wonderful thing is we're getting closer by the moment to finding the area of triangle 2. So with just a moment here, we have 45.96 or 46.0 if you would rather. You could say it's pretty close to 46.0. Now at this point, that's all well and good, but as we're looking at triangle 2, just want to point out the obvious that we don't have any angles, but quite frankly, we don't need any. The perimeter is just going to be really 40 plus X plus Y. So the semi-perimeter is just half of that. So look what we can do right now. This is kind of nice. We could store 1/2 40 plus X plus Y for S. So I'm going to do that right now. I'll go 0.5 instead of a half. You could make the fraction show up just as well. Oop, do you know what? I did not store my previous answer in there for Y just yet. I had Y solved for. If we hit enter again, we've got that. You might want to hit store and then hit alpha Y. So it got slowed down just a little bit. But now we have X and Y remembering those values. So real quickly now what you can do is take 0.5, type in X plus alpha 1 plus 40. I went a little bit out of order. Perimeter, of course, is going to be the same thing. You can immediately even hit store and hit alpha S. And right now we've got the semi-perimeter stored. We're going to use Heron's formula to find the area. And writing it out, I just want to state the obvious. It's semi-perimeter times semi-perimeter minus 40 times semi-perimeter minus X semi-perimeter minus Y. And we'll let the calculator work that out for us once again. So we'll have the square root, can just go alpha s, and then hit parentheses, alpha s minus 40 times alpha s minus x times alpha s minus y. And we could pretty much right now get that area about 839.6, roughly, somewhere around there. So for triangle 2, the area of triangle 2, we saw it was about 839.6. Now, of course, what's going to happen is we're going to add these other two areas together to finish this up. If you wanted to show all your steps, which is always a good thing, we could work those others out. But before I do, I'm going to say store this maybe in for alpha A. We'll call this, the area of triangle 2 is A. Triangle 1, well, we can say 0.5 times 35 times 80 times the sine of 15. We wrote it out, but we just never really evaluated that. How about I also store that for alpha B? I think you can see where we're going with this. You can see that's about 362.3. And then triangle 3 is going to be 0.5 times 20 times 45 times the sine of 80 degrees. And you could store that perhaps in another one. Oh, do you know what? I once again did not store that other value in. So tell you what, I'm doing the same thing here that I had done before. I worked out the 362.3. I think I might have talked about storing that in for alpha B, but I'm afraid I did not. So we'll just take a moment and go back and get that in there. Okay, and then real quickly, just finishing this off, 0.5 times 20 times 45 times the sine of 80. We can even hit store that in alpha C. And you can see we'd get 443.2. And real quickly, if you want to find the total, you can just say I want to add up A, B, and C. And you can see we'd get about 1,645.1. 1,645.1 square feet, evidently, because our units are in feet. That would be a good approximation for the area of that river.